Hi guys, like good evening. This is Tharun Naredla. I'm a like senior mechanical design engineer with like 6 years experience in product development and product designing. Basically I do work in kitchen appliances and other like robotic stuff. So I lead many projects from starting stage to completion, like Nerovel and Buchuk, um, and all, and like many all. Even like in my free time, like I used to conduct some webinars and guest lectures for the uh, students also. As I'm a mechanical engineer, like I'm having good knowledge in both additive manufacturing and automobile engineering and uh, many more like mechanical related things. So now like today I'm here to give you a brief introduction about 3D printing. Like you guys know anything about 3D printing?
Yeah, no, the response I was reading, Karan, no is little bit, no sir, a little bit, not too
Okay.
much. They are having a slight knowledge. That's it.
Okay then. Actually, there are like different types of 3D printing. So before going to that different types of 3D printing, like I will like to tell you what is 3D printing exactly. So 3D printing is a additive manufacturing technology. So basically, in manufacturing product, there are like different types of techniques: subtractive manufacturing and casting and additive manufacturing. So 3D printing will comes under additive manufacturing. So here, the material will be added on layer by layer to get the ultimate final product. So as these layers are like attaching to each other, adding to each other, so this manufacturing process will comes under additive manufacturing. Okay. So like history, going to history, like 3D printing was started in 1960s itself, like the concept and all. But like the first 3D print was done in 1980s, and that was like by using a technique called SLA. Like in the next slides I'm going to explain to you about what is SLA and all. And uh, as like the 3D printers are having n number of opportunities, the application of for the 3D printers are not scalable, so they can be used in anywhere. So from medical to like army, from one, like not only a dedicated place, like that can be used in like everything. So first of all, just I'm giving you a brief introduction about 3D printing. So how to make a 3D print? So to make a 3D print, first you need to like you can see my pointer, right? I think yes, you can see.
Yeah, Anna, it's visible.
Yes, yes. So first, like you need to have a 3D print physical part. First, you need to make that part in a modeling software. If you guys are from a mechanical background or civil background, even like some of the 3D print triple people also may know about CAD softwares and all. So there, like you can build your 3D models like in a required dimension, required geometry. So by using that softwares, like you can build a 3D model first. And like if you are from a like CSE background or like IT background, even you can get that models downloaded from a there are some softwares called Thingiverse, OpenSCAD and all. There by giving some like the required data by answering some questionnaire, you will be getting that 3D model ready by the application itself. So from there, from that model, you can download this STL file. Okay, so this STL file will be transferred to a slicing software. So basically, as I said, 3D printing is a additive manufacturing technology, where the material, like in the final product was like made by adding layer by layer. So first, to know that layer dimensions and like layer geometry and all, we need to make our 3D model into layers. So to convert that 3D model into layers, we will be using a slicer software. So that software will itself slices the 3D part into layer by layer by layers, and that layers information will be converted into G code, and that G code was directly sent into the 3D printer, and by using that G code, the 3D printer will 3D print the part. I think you understood the flow of how the 3D printing was done. I think like you guys can turn on your mic and you can answer, no problem. So I want my session to be an interactive, not like a like one-way teaching. So if you have,
They are like responding in the chat. I will be reading those for you.
okay, then like I'll join from another device so that like I can see the chart.
Yeah, sure. Like
Yeah.
so, basically, we can use different softwares for different part of our model. They're asking.
Uh, what? Once again.
Like so, basically, we can use different softwares for different parts, a different part or a model. To
No,
build
no.
a model, we use.
Yes, you can use any model, like any software for modeling anything. So they are like so so these are the different types of slicers. So all these are like slicers. So after your like for modeling, you will have AutoCAD, Fusion 360, OpenSCAD, Tinkercad. Even like nowadays, like design.ai, this is a software like where by giving a simple prompt, you can generate a 3D model. So all these three, like there are a number of 3D softwares. So there you can create your own required 3D file, like a 3D model. That 3D model by using these slicers. So Cura, Slicer 3R, all these are like slicers. Okay, in these slicers, when you put that STL file into these slicers, that will convert that 3D file into slices. So you can see here, like, so this is the 3D file, like STL file. This is 3D model, and this is like 3D STL file. After like doing slicing in the slicing software, that data will be given in a like layer by layer by layer by layer uh, format, and that information was stored in a G code. Like in the next thing, in the like in the coming slides, I will open my few of the G codes and I'll show you how that works also. And that G code was like sent into the mission, and again like 3D model. So these are the like different types of slicing tools. So there are some open source, and there are some like purchase kind of things are there. So in that, like you can use any of the things. So you can use any 3D model software or any slicer. The thing is, before slicing, you need to mention what type of 3D printer you are using. So with the type, there are like different types of 3D printers and different models of 3D printers in like every technology. Like if you go for FDM, if you go for SLA or anything, so they are like different makers of 3D printers. So you need to mention that thing to the slicer, so that the slicer will slice the file according to that printer. So first, like this is the like basic type of technology type of like 3D printing, fused deposition modeling. This can be also called as triple F, also triple F, FDM or triple F. So both are same, but like for sake of patents and all, so they are using FFF technology, fused filament user filament something is there like FFF technology, but because of that patents, we cannot use that FFF word directly. So now the same thing we can use as FDM, fused deposition modeling. So here you'll be having the material in a reels kind of thing, in a like string kind of thing. That string, basically all the strings are like thermoplastics. I think thermoplastics. Thermoplastics are the plastics which are having a physical property. When that was like heated up, that will turn from solid to plastic state, and like having a nature of like plasticity, such that like it can like brings catch the shape whatever we want. So here they are like the types of thermoplastics we are using are like PLA, ABS, PETG. There are like many more thermoplastics are there. So the main thing is here. So you will be having a heated nozzle here. So in that heated nozzle, there will be a filament or like a string which was inserted. As the like nozzle was like heated up, that filament like got melted up and turns into plastic state, and then this nozzle will be moved in the required shape or in the required directions, such that the plastic, like the melted plastic will be deposited in the required state, and the finally like here like you can see these are like first layer. So first like this will come from here to here, then like this layer will be deposited here, and then like that will move little up, and again like this layer will be deposited, and again like that will move little up, and this will be like in a cyclic process and in a controlled way till our required digit shape was done. This will be followed. So they are like to have a better idea, I'll show a video here first, so then I'll go back to there. If you see, like this is the heated nozzle, and the filament was like above this, like you can't see that now. So this heated nozzle will melt the filament, and that will like places deposits like wherever it is required. So I think like you guys understood how like this FDM technology like will be used in 3D printing.
Guys, try to respond through chats or like switch on your like yeah. The response is yeah, yes.
Okay, so that was like the basic type of. Sorry. Okay, now I
Fine,
can
fine.
start also here. Okay, so that was like how the FDM were like FDM technology works. So the advantage of this FDM is like this is the cheapest 3D printing technology. So here the only thing we need is just a thermoplastic and a heater and some setup to move the heater in a required path. So that may be by using some stepper motors and all, So in that way, like we can build these FDM 3D printers, and we can make our own 3D print. Like we can make our models by using this technology. So the only limitation for this technology, FDM technology, was low quality. So as in this technology, the final part was like made by adding layer by layer by layer by layer. So there will be a clearly visible lines on the outer side of the body. So you can see the lines where like that was like not a desired output for some of the applications. So that was the only limitation for this FDM technology. And another limitation was like here, as these are like parts printed are by using thermoplastic, so that will also again deforms or easily reacts to the temperatures. Like if we use that part at a like 60 to 70 degrees centigrade, that will like slowly deforms its shape as they are like made out of thermoplastics. So unless like apart from that, like the FDM like very good, and we can make like whatever we want, and this will very flexible and very useful 3D printing technology. This was like the first thing we need to learn in a 3D printing technology. And the second one was like stereolithography. So this is a kind of advanced technology used in 3D printing. So here, in the previous thing, in the like in the FDM technology, you are using a filament, like you are using a filament, like thermoplastic filament, which was like melted and placed in the required area and forms a required shape. So here this is like completely different. So here, instead of that plastic and all, we'll be using a resin. I think you guys are nowadays like you guys are like familiar with mobile glass cards, which was like applied by using a resin and a UV light. Yes, like I can see your chart. Like if yes, yes. So okay. So in the same way, so there like if you see that mobile, if you see that like mobiles glass guards and all, they'll pour a resin and they'll apply the glass and they'll put that in the ultraviolet like UV light. So that like by using that ultraviolet light, that resin got hardened up and that holds the glass and screen firmly. So here also in the SLA is like that full form of SLA is like stereolithography. So here also we'll use the same kind of resins, and the light, instead of like there we'll spread the UV light in a random and open way, but like here by using some techniques like some optical techniques, we will guide the laser to move in a desired way where we want the thing to be hardened up. So there like whenever the UV light touches the resin, that will harden up the resin, liquid resin into, and that will convert into a solid part. So again, after the completion of like one layer, that will be moving little up, and again the layer will be again the laser will like move in its path, so that like the second layer will also harden up. So in this way, the SLA will be used for 3D printing. So this also can be easily understandable by a simple video. I'll show that video also.
For stereolithography, a 3D printing process that uses a UV laser to cure liquid resin into hardened plastic. Upside down or inverted stereolithography is the most common SLA system. Depending on the machine, resin is either poured into a tank by a user or dispensed automatically from a cartridge. At the beginning of the print, a build platform is lowered into the resin, leaving only a thin layer of liquid in between the platform and the bottom of the tank. Galvanometers direct the UV laser through a transparent window at the bottom.
So here like these two are like glasses. these two are like glasses. So these glasses will be turned in a desired way such that the laser light will be projected to the to the surface of the liquid where the liquid need to be hardened up.
Of the resin tank, drawing a cross-section of the 3D model and
I think
stereolithography, a 3D printing process until recently. SLA was originally fresh resin flow beneath 100 microns thick, hardening the material.
see, I think like you guys can see this blue light, right? So this is the like light that was like guided onto the liquid surface. So by using this light, the reason like the liquid resin will be hardened up in this way.
The print is built in consecutive layers, each less than 100 microns thick. When a layer is complete, the part is peeled from the bottom of the tank, letting fresh resin flow beneath, and the platform is lowered once again. Originally developed in the 80s, SLA was confined to large industrial machines until recently. Today, desktop stereolithography offers affordable, high-resolution 3D printing that fits conveniently in your workspace. SLA allows for the use of a wide range of materials with diverse physical properties. Whether you're an engineer, product designer, sculptor, jeweler, or dentist, there's a material.
So
for stereolithography, a 3D printing.
Someone is asking like SLA is only used for small parts or particular 3D modeling. Not in that way. So compared to FDM, SLA is like little expensive and like little time taking. So basically, SLA can be used for like the things which are having high precision, which requires high precision and like high surface finish and high geometrical similarities. Like if we go for FDM, so where that is like a kind of thermoplastics, working with thermoplastics, after cooling that, like because of the temperatures, that may sometimes shrinks and that may have a little chances of like dimension deflections. But here in SLA, the dimensions will be maintained 100 like 99.9% accurate, and this will have good surface finish as like these are like working, the SLA is like working with the laser. We can like define the print up to like 50 microns. So there if we go for FDM, in the FDM the minimum thickness we can print is like 0.8 mm, so which is like around sorry sorry okay, in FDM, so the minimum thing, the minimum layer we can print in FDM is like 0.8 mm. So where here is like 0.005 mm we can print in the SLA. So that was the thing with the SLA, and we have like big SLA printers where we can print like a whole chair in a in a one stretch. But like the thing is, this it requires like high setup, and like the resin cost was like very high. So the no one will like try to print like use SLA for making that much like big parts. Can we print MCB or PCB by any 3D printing machine? Yes, you can. So they are like different type of materials, so which are having conductive nature and non-conductive nature. So by that, like you can print the PCBs also, and even like some like hobbies people will place their raw PCBs in like the copper PCB with like complete copper sheet. I don't know the exact name. So they will place that on the surface of this, and they'll pour the resin liquid, and they will project the laser light in the way where the circuit need to be done. So when this like resin harden up there in the like on the surface of the that probe board or all, so that then like transferred into a etcher. So only the required like the track will be covered with the resin, and the remaining thing will be will don't have any covering. So the etcher will remove that excess layer, and finally after that like we can remove the SLA thing by using some blade or anything. Then like you will be getting your PCB also. So this can be used for making PCB also, like by the hobbies. So but like if you want a proper PCB to be done, you can use FDM technology for like making a PCB, because like in FDM there are like different types of materials which are like conductive and non-conductive. Non-conductive can be printed for a base, and on that like in the exhaust track way the conductive material will be printed, so that like you can use that as a PCB also. Okay. And
It's for
like
stereo.
so they are like now these two, like the FDM and SLA are like majorly used 3D printing technologies in the industry in the current scenario. But apart from there, there are like many 3D printing technologies are there. So like I would like to like give you a very little intro about like that techniques also. Here like this is like SLS, selective laser sintering. So in this SLS, like the SLS also works with the same kind of technology with the SLA, but like here instead of resin, the SLS will be printed with the powder. So here the liquid was like hard enough. There the powder will be hard enough. So as here like the a layer of powder will be spread on the. Pardon?
Being
Hello.
I think someone is unmuted. I will unmute him.
Oh, okay. Okay, like same like SLA, instead of resin, here like the powder was spread on the layer. There like they'll use a laser to harden up that required area. Then like another layer of powder will be applied, and that also like harden up by the laser. So in that way, the layer by layer, that powder will be harden up, and the finally the required shape will be like will be getting from the SLS. So here also the SLS is also having less layer, less resolution, and like less layer quality, as like we need to apply the layer by layer powder. So the powder will have like a certain like what we call like unit molecule, like smaller unit molecule, right? So that so we can't make 0.01 or 0.02 layers there. So we can make like 0.03 to 0.04 layer heights there. So there we are not getting like proper resolution in the SLS. So but the things made out of SLS will have good, like very good strength and very good like physical properties. So like if you want to make a harder parts, so then like you can have this SLS technology. Here like coming to next technology, this is like DLP, digital light processing. So even this DLP is also an advancement for the SLA. Here the laser light will be used, and that laser light will be guided in the required path by using some optical mirrors and all, right? So but like in DLP, so directly a screen like same like our mobile screen, a UV screen will be there, and on that like the required part will be lit up in a UV light by controlling, by using like some control and all. So that UV light will harden up the resin, and that will make the thing like make the part in a required way. So compared to SLA, the DLP was like a little faster. Here in SLA, the light need to travel from one point to another point, one point to another point in every layer. But like here in DLP, so at a stretch, at a single stretch, the complete layer will be projected, so that that will like make out the things little faster than the SLA. And coming to the like next thing, binder jet technology. So here same like SLS, the powder will be applied in a layer, made in a layer, and on that, so there will be a binder liquid, like binder glue kind of thing. So that will be applied in the required path wherever it is required. So that liquid reacts with the layer of the powder, and that will harden up. So again, like next layer of powder will be applied, and next layer of like glue will be binder agent will be applied. So in that way, like that layer by layer will be done, and by using that, like this binder jetting technology will be used for making the 3D printing 3D prints. And here material jetting technology. So this material jetting technology will be like used for printing metals actually. So like even we can print like plastics and other materials also, but like metals can be printed very easily by using this material jetting technology. So to print the metal, so you will be having a nozzle same like our FDM 3D printer. So in there, instead of here, like instead of that filament, here we are using this metal powder, or like grinded metal. So that will be like sometimes that will use a plasma torch, or like sometimes that will use some resistance technology, such that that powdered metal will be melted, and that will be deposited wherever it is required to make the required 3D part. Okay. So in this way, this like material jetting technology will be used. In the same way, like even you can print metals in the binder jetting and SLS also, but they won't have that much strength as material jetting will have. So in the material jetting, that will be bonded by using some torch, or like some melting process. But there a binding agent will be used where like that won't have proper bonding to layer, so that like that will have some resistance, and that will have some drawbacks in it. Okay, you guys are like clear with this four types of 3D printing technologies?
Yeah, respond.
Yes, yeah, I saw. Yes. Okay, got it. So fine. So like so these are the applications under like can we have some like question sessions like before going for applications and all? Like if you guys have any questions and all, uh, like I'll answer that questions. So that like later I'll go for the application part, and then like I'll tell you the advancements in the 3D printing, and if time permits, like I'll show you how this like DLP, SLS, binder jet material things will work. So you guys don't have any questions, right?
Yeah, Tarun, you can move forward. I think.
Yes. Okay, then fine. Like then we have some more time, right? So then I'll open a slicer. Can we print everyday objects? Everyday object means like, yeah, we can print like now in my office also, like I'm using a mobile stand like a 3D printed, and even my bike have some 3D printed parts, so like where that can hold some bottles and some tools and all. So yeah, we can print like everyday parts by using 3D print. Does resin have a specific volume? Meanwhile, can I calculate whether a certain amount of resin is enough to print a particular object? Yes, like in the slicer itself, like that will give you the required quantity of the required volume of the part. But like thing is here, there will be a wastage of liquid. So I think like you saw here, like once I'll go back to the I'll play the video here.
Automatically from a cartridge. Platform, only a thin layer of liquid in between the platform and the bottom of the tank. Laser at the bottom of the resin tank, drawing a cross-section of the 3D model and selectively hardening the material. The print is built in consecutive layers, each less than 100 microns thick. When a layer is complete,
See, if you see here, the part what we want to print was like from here to here, right? But so the liquid was like all through this container. So here like we need to maintain a certain volume of liquid, but like later we can use that liquid for other part. But like we need to maintain minimum quantity of the liquid to print the parts in the SLA. I think like you got your answer. Um, okay, fine. And any question? Any more questions? Like, or can I show you how a slicer works?
You can move forward to the next topic.
Yes, yes. Like, then like I'll show you how a slicer works. So this is how a slicer looks actually. So you can get the parts from here. I think like I have at least like some parts in my system. Okay. So for now, like I'll so this is a slicer. So here this is like a creality print. You can see the screen, right? Yes. Okay. So here like from the open file. Okay. Okay. This is taking some time to loading. Okay. Select the file and open. So now like you can see that model here. Okay, so like instead of modeling and all, I downloaded it from the internet itself. So there, like this part I downloaded, and that file was like imported here. So now we need to give certain information to this actually. So before giving that information, we need to select the 3D printer actually. So there are like different types of 3D printers from different manufacturers. So there, like you need to select that 3D printer here. So the currently, like I said, like under 3 V3 KE is a type of 3D printer which was made by a company called Creality. So this uses FDM technology, and I said in FDM technology, nozzle was like used to print the filament, right? So the nozzle diameter is like 0.4 mm. So that was like included here. And after that, after selecting that 3D printer, so why we need to select this 3D printer is that will every 3D printer will have different dimensions in it. So if we go for if we go for this Creality under 3v3, so the mission height is like 440 mm, and uh, length and width are 220 mm. So you are having an idea of three geometry, right? Like as we are making 3D parts, so we need to have three dimensions. So in that three dimensions, one is you consider this as height as g, this is x, and this is y. So in this printer we can print as much as height of like 240 mm, and length as like 220 mm, and width as 220 mm. So this was the maximum capability of this printer. Okay. So for this sake, we need to mention the type and make of the 3D printer. And like if you see, so that was the actual dimensions. But like here, if you see this model, here the model dimensions are like 62.4 mm, and 85.93 mm, and 55.00 mm. So out of like 220 by 220 by 240, we are using only this much of volume to print this part. Okay. Okay, right. So after selecting that printer, and placing this model here, we need to define some things here. So as I said, in the 3D printer FDM technology, we need to print everything in a layer by layer by layer, right? Here we need to mention how much thickness of the layer you want to print. So for a very high quality thing, we can print like 0.8 up to 0.08 we can print. This was the maximum quality we can print. And here along with that, so we can change the first layer, second layer, third layer thicknesses also. We can give in different slicer, there will be a provision for different things. So here the main thing is layer height. So you can keep the layer height here. I'll keep the same as 2.0, and this will changes the layer thickness. And this is shell. So shell is nothing but if you see, I'll slice one part and I'll show you, so that that will be if you don't like the object you printed, no, in SLA you can't get that back. So as resin was hard enough, that was the end of that life. so you can't do that. Can you show us how will be the full pipeline to create a 3D model? Okay, I'll try to do that. What is the red, green, and blue in images? So these are like XYZ three axes. Like red is maybe x-axis, y is yes here. Violet is like blue g-axis, green is y-axis, and red is like x-axis. So after defining I think why I don't know. Suddenly my system got like a little hanging up. So if you clearly see, you can find why this is not working.
It's 7 o'clock.
Okay. I think you can see there are like some yellow lines here inside, right? Okay, so the yellow lines are like so when you print a 3D part, so the thing what you need is like the outer surface, not the inner thing. So if you like if you want to fill the part with like completely with the plastic thing, that will like may build up some weight to the part, or like sometimes like that will make the part little heavier. And as that the density was like, if the density was like too much, that will bring the physical property little what like little brittle, that will like easily break up. So to avoid that things, like we will fill the inside layers like very not 100% completely. Will like fill like with less density by using some strings. So that was like here the yellow lines that can be adjusted here. If I don't like the object in FDM, like you can do that, not in resin. In FDM, like you can shut down the part, as like FDM uses thermoplastic. If you shut down the part, like that will again convert into small pieces. You can melt it, melt that shredded pieces, and you can draw filament out of it, and you can use that filament again. I don't know, like my slicer got like hanged. I'll try to open it again. So here shell. So shell was like the outer layer. What was the like desired outer layer? So there also we can configure the number of layers required and the number of top and bottom layers required. So here like we can give that things here. And just now like I'm explaining infill, right? It is like not need to be 100% infill. So here like 15% is like pretty enough to build a like strong part in 3D print. So if we make like 100% infill, that will like build up some weight to the part, and that may lead to the like brittleness of the part. uh, and speed also, like here, like you can change the movement of the nozzle speed. So the nozzle will also move from one place to another place for like depositing the material, right? So there, like that will have some speed, right? That speed can be controlled here. So here this speed will plays a very important role in like 3D printing the things. So if we print the 3D if we print a part with the like high speeds, as like that will move up very fastly, that won't have like a precise coordinate dimensions, as like they'll if they as they are like moving up very fastly, they'll have some like deviation from the actual dimensions. So if we want like a precise print, so then like you need to print that in a low speeds. But like if it is okay for you, like if you want the print to be done in a quicker way, you can use like at high speed, and you can print at a high speed. So these are like supports. So if you see like consider an umbrella, can we print like a umbrella, like a kind of thing like similar to umbrella here in the 3D printer? Hello, yes or no? Anything, anyone from chat? I'm searching for a part like where I can show you something. Okay, I'll use the same model so that like we can. Okay. Uh, if you see here, I'll remove the lines here. If you see here, so the first layer here, bottom was like I'll slice and I'll show you. So that look that will. So here, like in the top, you can see. So these many number of layers, like this part is like sliced into. So if you see here, so there are some green extra parts like that was included into the part. So if that green lines are called like supports. So these green lines are called support. If you are not having these supports, so these parts need to be printed in the air. So can we place any thing in the air without any support? We can't, right? Same like our building slabs. So like same like our building slabs. So if you consider making a slab here, so you will like use some centering with a like maybe sometimes like they will use some metal sheets, or sometimes they'll use some wooden sheets. So by using that, like they will provide a bed, and on top of that they will place the material. So after hardening, you will be like they will remove the metal sheets or like wooden sheets, and the slab will be remains there. So in the same way, here they will use these supports will be used as centering and on top of that the required 3D part will be printed. Okay, instead of like printing the things in a air, we'll use these supports, and there like our required part will be printed. Now like I think like you understood why these supports are uh, needed to uh, needed in like in 3D printing. You understood it, right? Yes, yes. Okay, and like again I'll come back to the settings. Okay, like now you came to know what is quality. Quality is the like layer height. Shell is like the outer layer, number of layers of the outer layer. Infill is like the percentage are like of infill material. Speed, you know, like I explained. Support, like just now I explained. Materials. So here like they are like different as I said, like there are different type of materials. PLA, PETG, ABS, nylon. So different materials will have different temperatures, different melting temperatures. So that temperatures we need to mention here. So if you consider like PLA, that will melt at like 220 degrees centigrade, and if you go for like ABS, that will melt at like 240 degrees centigrade. If we go for like nylon or something, that will melt at 260 degrees centigrade. PETG again like 210 degrees centigrade. So they are like different materials which are having like different temperature ranges. So that temperature we need to mention here. So apart from this, like we need to maintain some build plate temperature here, 60 degrees centigrade. Um, so like okay, just like remember this build plate temperature. I'll explain you like after going to the like slides again. So these are the main things remaining, like cooling, extruder. So these are like uh, not that much considerable. So these are the like main things we need to consider like before slicing a part in a slicer. Okay, this was like for the 3D printer FDM technology. And this will be like only used for the FDM only, not for like SLA. For SLA you will be having a different slicer called Chitu box. Yes. Ravi, can I know the like till when like we can stay here?
Yeah, you can take over like until and
Okay, okay. If like
depends. Yeah.
yeah, like if it is like 25 to 30 minutes, is it okay?
Okay, that's fine. You can.
Okay, okay. Then. So
Yeah.
same like that Creality print, like we can in the Chitu box also we need to upload the model here. Where are the downloads? The same thing I uploaded here. So here like if you see this, so this part will be like upside down actually. So this will be printed in this way. Okay, in FDM like we can print in a normal way, but here in SLA we will print the thing from the bottom to top. Okay, here also like we need to like the shell and all, like here there is like not needed to mention anything here, like in SLA that will be taken automatically. The only thing here we need to consider is like supports. So this is loading up. Wait for some time. So here also like to print in SLA, this need to be uh, Okay, these need to have some supports here. If I make this thing upside down, then you'll get like more supports. See, now if you see, so same like last thing here also, as like if you try to print this in a like upside down way, so again we can't print these things in the air, right? So to have that thing a support, these supports are used. So in the Chitu box, like default, like they will provide with the basic supports. If you want like more supports, if like if you can, if you feel like this part is heavy and the supports are like not sufficient, again like you can add manually in the required, just like touch the surface and click it, that's it. So in this way that will like again manually add the thing. And now after all this, like we need to slice. Okay, now this part is like sliced. So now like you can see the layers here. So this is the required thing where the light need to be projected for the resin to harden up. You understood it, right? Yes. Okay. So after this, like this information was like converted into a G code, and that G code, but like we can send that to the machine, like by saving, or like by if that printer was like connected to internet, we can send like by using this send internet, like network sending, or like you can download the file and you can send it. What is G code? Okay, G code is nothing but like geometry code. I'll show you that again. Like I forgot to show you actually. I'll show you. So this is called G code actually. So G code is nothing but like geometry code. So here like this is like x 93.58, y 79.309. So these two are like xy coordinates. So if you try to plot a graph, so to plot a point in a graph we need like two units, x and y units, to plot a point, right? So this that information was like from this x and y. And G1 is a kind of mission code, like to move mission, like first layer, second layer, third layer, that will be like given by using this information, this G1. And this E is for like machining. So E is for like extruding the material. So if you see like slowly from 0.87 to you can see like this is like keep on increasing. So that means like the material is like keep on dispensing, right? So that's why like this is keep on increasing. But like here, if you see this x, y, z, like x and y coordinates, that will like either increase or decrease. You understood like what is G code, right? Um, uh, Hello, you understood like what is G code, right? Or like can I tell that again? Yes, okay, fine. So this is the G code. So this 3D part information was like converted into this G code by using this slicer, and now this G code was like we can directly connect a printer and we can input to the like send that to the printer, or like you can like you can download that to your laptop and you can copy that your pen to that to your pen drive, and you can use that pen drive in a 3D printer and you can print. So either way you can do either way like you can do you can transfer the file to the 3D printer to get it 3D printed. Okay. Like is this basic things are okay, or like you want anything to be explained? So actually, like we can do a like lengthier session. So where like from modeling to the final 3D print completion can be explained. But like later we'll see with the Ravi, so that like if we have like proper session, like we'll do that.
Yeah.
Okay.
Yeah. Like, is that session going to close, or like, would you like to continue?
Yes, like just like applications and concluding the thing. That's it.
Yeah, please.
So okay, as like there are no constraints for this 3D printing, this 3D printing can be used like in not like everywhere. So if you see for like aerospace and automobiles and all, so for everywhere, like before going for a actual manufacturing or like actual thing, we can get that print 3D printed and we can test that geometrically and like the strength and the fittings and all. Then like when we can go for the actual production, even like prototyping also. If you see many startups like us, like they are when they are like doing some robotics and all, so they want a part designed by themselves, need to be made physically. So if they go for a like traditional machining like CNC or turn like lathe and all, so that will make up some cost for them to make that part. And again, like not only cost, like that will take like more time getting outside and waiting for the fabricator to make, and after that like we need to bring that part to the office and we need to check, and like if again if we have any changes, again we need to take that part to him, and like we need to do changes there, and like we need to bring that. So this was a like lengthy process, right? So instead of that, like we can use this 3D printer in the office itself. So there like we can print whatever the parts we want to do, and we can check here the tolerances, the fit, and the like the geometrical constraints if we have anything. So for that, like this 3D printing like was very useful for the prototyping. And and going to the medical devices, nowadays like if you see, so there are some parts like ears and nose are getting 3D printed. Even if you have after having a root canal, like you'll have a teeth like a prosthetic teeth, right? So that like also nowadays like they are scanning with the 3D scanners, getting that dimensions, and like that is also getting 3D printed by using SLA technology. So by using that SLA technology, that teeth also got get like getting printed, and that also can be used directly. And even like jewelries also. So when we are having like critical shapes in the jewelry, so that was like little hard for the craft people to make. So but like there like we can use this 3D printing technology to get that thing to be done. So where the like a lot of efforts of the artists can be saved by using this 3D printing in jewelry sector also. And here in like as I said, like as I explained you previously, in aerospace and like automobiles. So nowadays like these racing cars and all steering wheels are like getting made with the 3D prints, so that like that will have good strength and that are having very less weight. So I think like you are aware of that each gram of a in a racing car is like very valuable. So they'll use these like 3D printed parts to avoid to reduce the weights and to get like proper strength in the automobile fields also. So that was like applications of the 3D printing. So like I'm telling you again, this 3D printing can be like used in everything. So that was like about applications. And what was the like future of 3D printing? So nowadays like in everything the AI is like included, right? So AI is a part of everything. So from what like from making Excel sheets to like writing codes and everything, like the AI is included. In the same way, in the 3D printing technology also, if we integrate the AI and automation, so that will like makes the things like more easy and more simplistic. Okay, I forgot to turn on the slideshow, but okay. Okay, that will like makes the thing like more easier. And coming to the like other other way. So these 3D prints are like nowadays are capable of 3D printing human parts like by using some bio printable materials. So these 3D printers are like used to print ears and nose. But like if anyone had an accident and like they lost their nose or like a part of ear, so that part can be 3D printed, and like that won't like be a normal muzzle kind of thing, but that was made out of a bio particle, so that we can wear and we can like give a normal look, normal like look like actual part. So in that way, this like 3D printing can also be used in like bioparticles. And so like someone asked here like is that like filament reusable? Yes, it is reusable. So the sustainability is the like main thing nowadays. Like as we are wasting we are utilizing lots of plastic, which is like again brings lots of carbon number to the earth, like where that will like leads to the global warming and all. So here the material what like the plastic materials what was used in the 3D print 3D printing can also be recycled. And not only that, like if we go for a traditional machining, so to make a like 100 by 200 100 by 200 part, for that like we need a bigger part, so where that excess material will be removed, and that removed material is like wastage. So but here in 3D printing we are not like removing anything, it's just we are adding the part wherever it is required, so the material wastage will be reduced. Okay, that was like another like future in sustainability. And uh, so fine, these are like the futures of the 3D printing technology. I think you enjoyed like this workshop. Yeah, like that was like end of the so like if you have any doubts regarding 3D printing and all, you can reach out to me. This is my like LinkedIn profile.
Feel free to contact our speaker, and Thank you. That was a great and insightful session from Tharun. And thank you. A big thanks from Slate Valley for accepting us and coming here and accepting our session. And I hope everyone here are enjoyed session in 3D printing and great. They got great insights regarding 3D printing. Thank you, Tarun, once again on behalf of Slate Valley.
Thank you. Thank you.
Yeah. And guys, if you have any doubts, you can directly reach out to the Tarun through his LinkedIn, and you can reach out through mail also. Okay. And tag him, mention him in the LinkedIn. Tag him there.
Okay.
Thank
Thank
you.
Yeah, thank you guys. Thank you to the Slate Valley for giving me this opportunity to express my words regarding 3D printing. Thank you to Ravi for bringing me here. Thank you so much for this opportunity.